Okay, now I want to write a little simple function. I will give it name f, and it has following type signature. It takes some type A and maybe some different type B and returns to me a list of A. And I want to take these values A and B and put them into the same list. But because in Haskell the list is not heterogeneous list, I can't do this. But in some case A and B can be equal, and in this case I can take these two values and put it into the list of type A or a list of type B. This is no matter if they equal. How can I pick up this case then these two types equal in Haskell? Okay, to do this I need to import some module. I think this is the data type equality module. And here what they have? The idea to provide to Haskell some term level value, and if this value we have this value on at our runtime, we can say that A and B is equal. Okay, what this is a value? This value is a simple constructor. It's called raffle. And if you look at its type, you can see that it has this type. And now let's look at some information about this type. You can see that this type is defined like this polymorphic type, which takes two type parameters A and B, and it can be constructed only for such case in which this A and B equal. You can see this here. So it has only one constructor raffle, and this raffle constructor is say to us that we can construct this type, this polymorphic type of A and B, but in the case of this construction the types these types will be equal. Okay, if we construct it, the A and B is equal. This is somehow like a proof. Okay, now let's go back to our function. As I say, in this function I want to catch the case when the A and B are equal, and to fix this case I need to provide here additional parameter which will provide to me this proof that A and B are equal. So what is the type of this parameter? Of course we need to provide this raffle here, and it has this type from A and B. So we use this data definition to define its type. It's constructed from A and B, but it can only be constructed if this A and B is equal. Okay, and of course we can be in the case when our types are different, we can't provide this value, and that's why we need maybe here. So maybe we have the proof that a and b equals, and maybe we haven't this proof. Okay, now let's try to define this function. I will go to the multi-line mode and put this type signature here. And now, what if I in the nothing case? If I have no this proof, I have this x and y, and I can't create the list of a, which constructed from the first and the second element, because the list must have the same type of the elements. But here I can modify this type. I can say that here I not return a list, I return either a list of a the pair. So, and the pair will be for the case then a and b are different. Okay, let's I need to redefine this type signature. So I think like this. I need either here, and this either has either pair A and B, either the list of A in the case if they equal, A and B equal, or maybe this a list of B, doesn't matter, I will take A. Okay, in the case if they have the proof that if they haven't raffle, we didn't provide the raffle, this means that A's and B's A and B may be different. They are different. Actually, they're different, I think. In this case, interesting that they can be same also. Okay, we will see this later. So in this case, I have this x and y, and I can construct the pair with the left, the different type of elements, x and y. And in the case of just, if I have the first parameter just raffle, this gives me the proof that x and y are same, and this equality gives me ability to put this first argument and this and the second, all these two arguments inside one list. Okay, I think like this. And of course I forgot about some definition, so I need to replay this. And I need to put this is bad. Okay, let's try again. They define in the nothing case, they define it as a left, and in the just case I defined it as a right. Okay, and now they can see that it accepts the definition. And what I can do now with this function, I can run it if I provide nothing, I can use the different types, and you can see I get this pair, But if I provide a proof by providing the just of raffle, I determine that A and B are equals, and I can't use the different types here, so I need to have the second element of the same type as the first, and I get this list in this case. Okay, and now let's look. If I provide, if I don't know, if I provide nothing here, can I use the same type in this case? Of course I can, because A and B may be also equal, and our pair can be constructed for these as different types as an equal types.